Bang! Another hit on Jupiter. Let's see. Gas giant, the largest planet in the solar system, 318 times bigger than the Earth, 2.5 times bigger than the rest of the planets in the solar system put together. One more interesting thing. If it got any bigger, it would actually become smaller. You see, with more mass, the planet would be denser. That would cause Jupiter to start pulling in on itself. Scientists say Jupiter could have 4 times greater mass, but still keep the same size. It takes 10 hours to make a full rotation on its axis. It's the fastest spinning planet in our solar system, and gets hit by so many space objects all the time. This was discovered by amateur astronomers observing Jupiter and saw some unusual flash at the planet's surface. Impact events cause flashes like that, and for some reason, Jupiter gets more impacts than other planets. In 1994, astronomers discovered Shoemaker-Levy 9, a comet that broke apart and collided with the gas giant. The original comet was approximately the size of one that erased the dinosaurs. However, this asteroid fell apart into more than 20 fragments. They darkened the planet's surface, and it remained like that for months. 15 years later, in 2009, astronomers saw a black spot on Jupiter, the size of Earth. It was the result of an asteroid around 650 to 1650 feet in size. The biggest asteroid recorded on Earth hit the area of Tunguska, Russia, in 1908. This caused a massive explosion, even though no one ever found a crater. So, why is Jupiter the target for so many space objects? Asteroids and comets that pass by Earth and Jupiter go almost at the same speed. The number density of the space object that may interact is almost the same too, but the cross-section of what they might hit is very different. Jupiter has 11 times the diameter of our planet, which means it has around 125 times the cross-section. The more massive some planet is, the stronger its gravitational attraction, so it will entice some space objects drifting by. Our gravitational field is weaker than Jupiter's. If some object passes near us, moving at a speed of 20,300 or less, our gravitation will attract it. Asteroids and comets usually move at bigger speeds. Jupiter attracts most of the comets and asteroids passing by. If our planet was hit by such big objects as frequently as Jupiter, we'd have extinction like with dinosaurs thousands of times more often. In 2020, scientists found there was an unusual asteroid in the orbit of Venus, the first one there, the size of a small mountain and rich in minerals we can find in Earth's deep rocks. They even think it could be a clue to a bigger set of asteroids created when our solar system was forming. That's not the only mystery around Venus. The planet has insanely violent winds that drive clouds and storms around the planet at speeds greater than 220 mph. That's 60 times faster than Venus itself rotates. Also, scientists are still not sure what happened with its oceans. They believe since the planet is so close to the sun, the water evaporated and went into the atmosphere as steam. It trapped heat coming from the sun, heat that would have vaporized more and more water over time. Venus probably had an environment like on Earth, but a very long time ago. The theory says many comets and asteroids were slamming into Venus. Billions of the planet's pieces were flying all around. Some may have even crashed into Earth's moon. Pieces that slammed into our planet are probably buried very deep since we have greater geological activity than the moon. Uranus also had a collision, but a more serious one than asteroids. The rest of the planets in our solar system mostly have an axis of rotation that kind of points up from the ecliptic plane. Uranus is tilted, lying on the side, so a season there lasts 42 years, when either its south or the North Pole is pointed at the sun. Most of the planets also rotate counterclockwise when you see them from above our solar system. Venus does the opposite, which means maybe it was kicked off axis a long time ago. Uranus may have collided with the other space body millions of years ago. When our solar system was still very young, the orbital configuration of Saturn and Jupiter may have crossed. Their gravitational forces kind of created orbital momentum and transferred it to Uranus. That knocked it off axis. Millions of asteroids orbit the sun, and not so many pass by Earth from time to time, so we don't have some dangerous space bodies coming toward us. The plan is to visit Mars in the 2030s, and scientists hope Mars won't be a target of some bigger space bodies. New craters are formed on Red Planet every 1 or 2 days. They can be 13 feet across, which means they could have been formed by objects that are the size of a soccer ball. Since the atmosphere there is thinner than ours, smaller bodies can enter easier. Most of the Martian north is smooth lowlands. The south is higher, full of craters, and the planet's interior has a surprising amount of rare metals. The theory says this is because a big celestial body collided with Mars and tore away a part of its northern half. Debris from that asteroid circled the planet and then mixed into 2 small moons that orbit Mars. We also have some Mars rocks on Earth, found in the Sahara Desert, Antarctica, and some other places across the globe. Some of those rocks have gas that's chemically the same as the atmosphere on Mars. Rocks probably came due to a big explosion that happened when some larger asteroid or meteor that was ejected from Mars and landed on our planet. Mercury also has a thin atmosphere, so there are many smaller strikes there. Imagine waking up, going to your window, and see there are micrometeor showers every morning, which is something that happens on Mercury. This strange weather pattern shapes its atmosphere, called an exosphere. Mercury is so dense, its heavy iron core accounts for 2/3 of its total mass. Scientists think it could have been bigger in the past, but many collisions got the surface scraped off. It's been constantly bombarded by rocks from space that left marks with craters. Plains on its surface seem to have been created because of volcanic lava spilling over the surface and then dried smooth. Many craters are filled with such a material, which means there's one more thing that rocked Mercury's world: volcanoes. There's an unusual group of asteroids discovered near Neptune. Wide range in sizes, from big metropolitan areas to tiny pebbles. They are thought to come from an asteroid group called Kuiper Belt. It makes a ring well beyond Neptune. But these new asteroids have different colors than the Kuiper Belt. They're so far away from the sun, their surface was supposed to stay almost pristine, but they have a similar color to those sun-baked asteroids around Jupiter, like the rest of the planets. Neptune gets heat from the sun, but there's something mysterious inside the planet that makes it generate more heat than it gets. This affects its weather, and Neptune has the weirdest weather in the whole solar system. Massive storms, insanely high winds, cirrus-like clouds that rapidly change all the time. There are dark spots in its atmosphere. They come and go. We receive 1,000 times more sunlight than Neptune. Gas giants like Saturn and Jupiter can protect our planet from asteroids. Without them, the big impacts that created enough debris to form both moons and other planets would happen more often. There's a huge asteroid going towards Saturn, which could be a potential flyby in 2031. More than 10 times bigger than the asteroid that erased the dinosaurs. Titan, one of the moons orbiting Saturn, 80% more massive than our moon, is actually the only moon in our solar system that has an atmosphere. It's 1.5 times thicker than ours, moon, and consists mainly of nitrogen, like our atmosphere. No one knows where all that nitrogen came from. However, unlike Saturn and most of the other places in our solar system, its moon has a real potential to host life. This year before September, a star in the constellation of Corona Borealis will explode, and in the northern hemisphere, we'll be able to see it with the unaided eye. This star is T Coronae Borealis, a white dwarf star 3,000 light-years away from our solar system. It will turn into a nova, which we'll discuss a bit later, in spring or summer. Even though this occurrence is predictable, happening every 80 years, it's still a once-in-a-lifetime event if you're a human. T Coronae Borealis is not your regular star. It's actually a binary, 2 stars orbiting each other. This pair, though, is incredibly special. Occasionally, the stars increase their brightness to such an extent that they become visible on Earth. The white dwarf star is the more massive one of the two, but the most shocking thing about it is that it might pack the same mass as the Sun into a volume only as large as Earth. The companion star, an aging red giant, has already expanded so much that it's dumping its material onto the white dwarf. So, it's time for another explosion for these two. It's going to take the star's brightness from magnitude 11 to magnitude 2. In astronomy, magnitude is used to measure the brightness of a star or another celestial object. The brighter it is, the lower the number assigned as a magnitude is. In our case, it means that we'll be able to see the star with the unaided eye, even in light-polluted skies. Now we can only see the binary with binoculars in a completely dark sky. After the outburst, T Coronae Borealis will remain the brightest star in the constellation of Corona Borealis for a few days before gradually dimming. This event shouldn't be confused with a supernova. In a supernova, a star's core collapses, which leads to its complete destruction. It can only happen to a star 8 times the mass of the Sun. Instead of disappearing in a blinding flash of light forever, T Coronae Borealis will experience a nova, an explosion on its surface, flinging matter into space but not ruining the star itself. Such recurrent novas happen at regular intervals. T Coronae Borealis was known to astronomers of the past as the Blaze Star. Last time, it exploded in 1866 and 1946. Astronomers from NASA believe that it's going to do it again before September this year. The constellation of Corona Borealis, also known as the Northern Crown, is one of the most beautiful out there. It's a curved semicircle of 7 stars, which is easy to find in April. You should go outside 2 hours after dark and look to the east-northeast. Once you find the Big Dipper, use the curve of its handle to go arc to Arcturus, finding the bright star in the Bodas constellation due east. If you go diagonally down to the east-northeast horizon, you'll spot Corona Borealis. If you want to observe the brightening of T Coronae Borealis, it might be better if you get acquainted with the region and the stars of the constellation it's in. Once the event begins, you will be able to compare its brightness against the other stars and observe the thing without using any fancy cameras. A nova is a short-lived, sudden explosion, involving a compact star as large as Earth or a bit bigger. The outburst comes from a white dwarf circling remarkably close to a regular star, so close that a stream of gas flows between them. This gas starts piling up until it creates a layer on the white dwarf's surface, and then it reaches a point where it detonates in a runaway thermonuclear explosion. According to astronomers, around 50 novae happen each year in our galaxy, but not all of them are noticed. NASA's Fermi Gamma Ray Space Telescope has observed several novae that occurred not far, on the scale of the universe. They found out that each blast produces gamma rays. Those are the most energetic forms of light. Researchers also think that these gamma rays result from collisions among numerous shock waves racing from the explosion site in a quickly expanding shell of debris. Now, after we've talked about novae, it's time to discuss something much more dramatic: supernovae. It's the largest explosion humans have ever seen. Each blast is a super powerful burst of a star. One kind of supernova is caused by the last hurrah of an extinguishing massive star. It happens to stars at least 5 times the mass of our Sun. Once they near the end of their lives, they go out with a ginormous bang. Huge stars burn incredible amounts of nuclear fuel at their cores, producing tons of energy. It makes their centers immensely hot. Heat generates pressure, and this pressure keeps such stars from collapsing. But any star is in balance between 2 opposite forces. Its gravity attempts to squeeze the star into a tiny, tight ball, and the nuclear fuel, burning in the core of the star, produces powerful outward pressure. Now, when a giant star is running out of fuel, it starts cooling off. Its pressure drops, and gravity wins. The star collapses. An enormous object that is millions of times the mass of Earth collapses within 15 seconds. No wonder this brisk process produces enormous shock waves. It makes the outer layers of the star explode. Eventually, an incredibly dense core is all that is left behind, besides a growing cloud of hot gas called a nebula. A black hole, the densest object in the universe, is the result of a supernova of a star around 10 times as massive as our Sun. There's another type of supernova. It usually happens in systems where 2 stars orbit each other, and at least one of these stars is a white dwarf the size of our planet. If such a star collides with another or pulls too much matter from its neighbor, it can explode into a supernova. Also, supernovae are often so bright they can outshine the combined light of entire galaxies for several days, or even months. Supernovae aren't common. Astronomers think just a few of them occur within a century in galaxies like our home Milky Way. But since the universe contains an enormous number of galaxies, we can observe a few hundred supernovae every year outside our galaxy. Unfortunately, space dust blocks our view of most supernovae happening within the Milky Way. Betelgeuse, a late-stage red giant, exploded in 2019, but it wasn't the event we expected to see. This star is found in the constellation of Orion and is huge, so big that if we moved it to the middle of our solar system, its outer edge would go way beyond the orbit of Jupiter. When Betelgeuse eventually nears its end, it will explode in a stunningly bright supernova visible on Earth even during the day. This explosion could happen as soon as tomorrow or as far-flung as hundreds of thousands of years from now, so don't hold your breath. But then, what was it in 2019? Astronomers noticed that the star was dimming. They decided it was the initial stages of the grand show, but instead, Betelgeuse went back to normal over the course of the next few months. Further analysis revealed that the star hadn't dimmed. It just looked like that because we had been observing it through a cloud of stellar debris. At the same time, the amount of light in the photosphere of Betelgeuse ramped up. It was like a massive explosion of material from the surface of the star. Events like this occur on the sun all the time, especially when our star's activity is high. Bits of the sun's surface get tangled up and cast off. That's what we call coronal mass ejections. They do not harm our planet, but they can mess with satellites and electrical equipment. Getting back to Betelgeuse, we've never seen such a huge mass ejection of the surface of a star before. It's a new phenomenon, which we can observe directly and even see surface details with the help of the Hubble telescope. Astronomers say we're watching stellar evolution as it happens for the first time. So, Mars has two moons, Phobos and Deimos, and apart from the bizarre shape, there's nothing remarkable about them. Except for one thing. Not so long ago, scientists discovered a strange phenomenon on the surface of Phobos, and they still can't find any explanation for it. What is this phenomenon? And what does it tell us about the history of our solar system? Let's find out. American astronomer Asaph Hall discovered Phobos and Deimos back in 1877. Do you know that all the planets in our solar system are named after Greek and Roman deities? For example, Mars, or Ares, is the famous deity of war. That's why the satellites of this red planet were named after the sons of Ares, Phobos and Deimos. These beautiful names actually have creepy meanings: fear and horror. In 1971, NASA's Mariner 9 telescope took their first pictures. That's how we found out that these guys weren't at all like our moon. They had this weird shape, a strange and unstable orbit. Moreover, there are no other moons in the solar system that move as close to their parent planet as these two. Well, they are its suns, after all. But even though they're very close to Mars, if you were standing on the surface of the red planet, you would hardly be able to see them. That's because the curvature of Mars hides Phobos and Deimos from view. Even if you were somewhere on the equator, Phobos would look like an ordinary asteroid to you, and Deimos would look like a star. All because these satellites are basically crumbs compared to our moon. They're the smallest and least bright moons in the entire solar system, which is ironic considering their mighty names. Anyway, it seems that everything should be pretty clear with these two satellites. But nope, there's a problem. You see, scientists reconstruct the history of space based on the traces found on different space objects. Dents, scratches, cracks, all these things can tell us what happened billions of years ago. For a long time, scientists were sure that, just like their Greek prototypes, Phobos and Deimos were twins. But then, NASA's Viking orbiter took new photos of the satellites. And that's when they discovered a significant difference between the two. The entire surface of Phobos was covered with huge grooves. Those were a series of long, deep pits stretching from one end of Phobos to the other. You may say, What's the big deal? All space objects have this kind of stuff on them. And yeah, there are other satellites with similar grooves and scratches, but none of them has as many as Phobos. It's completely covered in grooves, and they're huge, up to 12 miles long and 660 feet wide. And that's not all. Some of these grooves intersect with others. This means that Phobos has experienced not one, but many traumatic events. But what exactly happened to it? Actually, scientists are still not completely sure. However, they have a few ideas. And these theories can tell us not only about the past of Phobos, but also predict its future. Theory 1. Asteroid impact. Well, the first suspect is quite obvious. There's a large, almost 6-mile wide crater on Phobos. It's called Angeline Stickney. It was named after the wife of Asaph Hall, the scientist who discovered the satellites. Adorable. So that's what the first theory sounds like. Once upon a time, an astronomical body crashed into Phobos. The impact was so strong that it left a large crater. And the effect of the collision left a bunch of grooves everywhere on Phobos. It sounds logical at first. However, scientists have noticed a flaw in this theory. They've learned that these grooves actually formed not inside the crater, but next to it. So it wasn't a collision that created them. Besides, what about those grooves that intersect with others? Or is it just a big cosmic coincidence? Well, the search for truth continued. Theory 2. It's all because of space debris. Yes, there's a difference between these two theories. In this case, the grooves aren't a direct consequence of the collision. Rather, it goes something like this. Something crashed into Phobos. This impact caused a bunch of rocks to be thrown into space. Some of them were lost in the universe forever, but others were small enough to be pulled back to Phobos. Passing next to the moon at a steep angle, they could crash into it, jump away, and so on. And since the gravity of Phobos is very weak, perhaps they couldn't stick to it. In other words, these rocks were continuously pulled toward and pushed off of the satellite for many, many years. This theory explains the intersecting grooves. It's because the rocks were constantly falling into those places. It sounds quite logical, but there's another problem. We don't see any boulders on Mars or on the surface of its moons. But all this debris was supposed to get trapped by gravity and remain somewhere in the planet's orbit. This, or simply become a part of Phobos. In other words, if this were true, we'd find evidence of this theory under layers of dust. But that didn't happen. So this explanation didn't satisfy astronomers either. Therefore, they continued to look for the culprit. Maybe the grooves have nothing to do with Stickney Crater at all. Maybe the real culprit is something else, something even more powerful. Could it be Mars itself? Theory 3. Mars is a twist villain. The previous theories imply that Phobos and Deimos were originally pieces of Mars. Like, once upon a time, they broke away from it and became satellites, just like our moon. But what if that wasn't the case? Observations made by NASA's Mars Global Surveyor show that Phobos and Deimos are made up of elements which are mainly found in meteorites and asteroids. So what if Phobos and Deimos are asteroids? There's an asteroid belt between Mars and Jupiter. Given the size, shape, and composition of Phobos and Deimos, scientists have suggested that once upon a time, they belonged to this belt. However, one day they flew out of it, and then gravity pulled them to Mars. This phenomenon is called asteroid capture. It's very strange, though. Yeah, the asteroid capture isn't uncommon, but these two have been flying next to Mars for what, billions of years? It's weird that their orbits have remained the same. In addition, the atmosphere of Mars is very rarefied, and because of this, it could hardly capture any asteroids. In theory, they should have separated from Mars at the first opportunity. However, this didn't happen. It means that somehow they got stuck, and Mars immediately began to destroy them. Yep, an unexpected twist. In this version, Mars turns out to be a villain. By studying the past, we've found some evidence of future crimes. The mysterious grooves of Phobos could be caused by tidal forces between Mars and Phobos. The Moon and Earth also exchange these, slightly distorting each other. But since Phobos is much closer to Mars, the impact of the gravitational forces is much stronger. In other words, the gravity of Mars is gradually destroying Phobos. Every 100 years, the satellite gets 0.7 inches closer to Mars. It also shrinks as much as 6.5 feet, becoming even more fragile and weaker. The smaller it gets, the more the tidal forces impact it, creating strange grooves and scratches on Phobos. Yep, somewhere in 30-50 million years, Phobos will either collide with Mars or disintegrate and turn into a bunch of small rocks. And then Mars will also have rings, like Saturn and Neptune. That's why Phobos is also called the doomed Martian moon. Anyway, these are all only theories, but the dramatic backstory of Phobos gives us an idea of how dynamic extraterrestrial objects can be. The more we learn about them, the more we discover about the secrets of the origin of not only Mars, but also other objects in our solar system. If one day we really colonize Mars, studying its moons can help us a lot. Let's hope that the upcoming MMX, Mars Moon Exploration mission, will reveal some of the most exciting secrets Mars moons are hiding. Imagine a black hole, a terrifyingly dense space object, pulling inside everything that comes too close. Nothing can escape its clutches, even a beam of light. And now, imagine two of these space monsters colliding. Scary? You bet! Astronomers have spotted two supermassive black holes feasting on the cosmic material of two merging galaxies in distant space. This phenomenon is the closest to colliding black holes we have ever seen. Supermassive black holes are the largest among all black holes out there. Their mass can be hundreds of thousands or even millions to billions of times larger than of our suns. And two such giants have been recently spotted with the help of an array of telescopes in northern Chile's Atacama Desert. Astronomers originally used these telescopes to watch two merging galaxies located approximately 500 million light-years away from Earth. Thanks to being alert at all times, scientists have also noticed that two gigantic black holes were growing alongside each other. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, only 125 million times larger. We can't see black holes directly. If you were to travel to a black hole, you wouldn't notice it until it was too late. The only detail that would give away the approaching black hole would be a slight blurring of distant stars due to the hole's gravitational lensing effect. The two black holes we are talking about are no different. They aren't visible directly, but are surrounded by bright clusters of warm, glowing gas and stars. All of this has been tugged close by the black hole's gravitational pull. Time will pass, and these black holes will start circling each other, and eventually they will collide, creating one, probably even bigger, black hole. Scientists have been observing these black holes across multiple wavelengths of light and have come to the conclusion that they are unique. They're located the closest to each other astronomers have ever seen. The distance between them is a mere 750 light-years, which, astronomically speaking, is just next door. Even more exciting, this distance is close to the limit of what modern technologies can detect. The thing is, such ginormous merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe those bright and compact regions where matter swirls around the black holes. Imagine how surprised astronomers were when, instead of one black hole, they discovered two of them, munching on the dust and gas stirred up by the massive space merger. Galaxy mergers are way more common in the distant universe than in our neighborhood, and this discovery may mean that such black hole binaries are likely to be much more common than we previously thought too. And if pairs of black holes are so common, it might make it easier for us to study gravitational waves. These waves, also known as ripples in space-time, occur when black holes collide. If we talk about the recently discovered pair of black holes, it might still take them several 100 million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes there are that are about to collide in the universe. Also, this may give us more insight into what is going to happen when our home Milky Way galaxy collides with the Andromeda galaxy in around 4.5 billion years. By the way, the first photo of a black hole was taken in 2019. An international team of scientists consisting of more than 200 astronomers had been working for years to get this result, and their efforts finally paid off. The object in the photo is about 55 light-years away from Earth, at the center of the galaxy M87. You can now admire this amazing space phenomenon thanks to the work of a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. The event horizon is a point of no return on the outskirts of a black hole. Once something, for example, matter, radiation, or light, reaches this boundary, there is no way for it to escape. To capture the very first image of a black hole, scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 radio telescopes. But it wasn't an easy feat. The researchers had to simultaneously point the telescopes in a meticulously planned order, with the help of precise atomic clocks set on each telescope. Plus, they were constantly monitoring the amount of moisture in the air, since too much humidity would ruin the images. To keep the chances of rain to a minimum, they even constructed the telescopes in super dry regions, such as the Atacama Desert in Chile and the South Pole. All in all, the process resembled a carefully coordinated dance. But thanks to these preparations, in over 2 weeks, the telescopes collected 5,000 trillion bytes of data. It was then processed by several supercomputers, and scientists finally got the long-awaited images. And what they observed was a monster of a black hole, measuring about 25 billion miles across. Now how about we talk about the coolest black hole facts? There are baby black holes called primordial, and they are really tiny. They vary from the size of an atom to that of a mountain. There is a theory that galaxies get formed around black holes. This means that when a large star explodes, a black hole appears in its place, and then the rest of the galaxy just forms around it. There is a supermassive black hole right in the middle of the Milky Way galaxy. Its name is Sagittarius A star, and it's 4 million times as heavy as the Sun. And nope, we aren't going to be pulled into this hole. It's more than 26,000 light-years away from Earth. That's too far for this monster to have any influence on our planet. Besides Sagittarius A, there are 100 million medium-sized black holes in our galaxy. And can you imagine how many black holes in total there are in all 100 billion galaxies that exist out there? You do the math. If you ever find yourself near a black hole, be ready that time will slow down significantly. It may work for you if you aren't so eager to grow older. Just don't let yourself be tugged into the event horizon. Whoops! Bye-bye! Black holes aren't some hungry predators that roam the universe preying on poor, unsuspecting planets. They just gulp down the stuff that ends up too close to them. On top of that, they sometimes fling out spitballs the size of a planet. How does this matter escape the pull of black holes? Typically, it manages to slip away before going past the point of no return. In fact, with Sagittarius A, we should be worried not about its gravitational pull, but about the very spitballs. After all, the monster black hole hurls them in the direction of Earth at a speed of 20 million miles per hour. What if one day one of them reaches our planet? If you manage to squeeze Earth to the size of a cherry tomato, it would turn into a black hole. In fact, you could also become one if you agreed to be scaled down to an atom. South African astronomers have recently come across another head-scratching black hole mystery. In a region of distant space, they noticed that several black holes located in different galaxies aligned in the same direction. It looks as if their gas emissions have been synchronized by design. Nowadays, scientists can't explain why and how black holes, which are about 300 million light-years away from one another, can be acting in unison. It's a puzzlement. Look at this blazing monster. It's a white dwarf. These stars are known for gobbling up passing objects, and one day, these objects might be the planets of our own solar system. According to a new study, parts of the solar system will be pulled into a white dwarf star, crushed up, and eventually ground into a fine dust like coffee beans in a blade grinder. You like that analogy? White dwarfs are the final stage of a star's life. It's a small but very dense star that is typically the size of a planet, the result of a low-mass star exhausting all the nuclear fuel in its center and losing its outer layers as a planetary nebula. When our sun turns into a white dwarf, and it is bound to happen, it'll destroy the asteroids and moons around Mars and Jupiter. They will be pulverized by its gravity. Earth, though, will be swallowed up even before the sun turns into a white dwarf, but it won't happen for another 6 billion years. Researchers working on this topic have come to such conclusions by observing what happened to space bodies, asteroids, moons, and planets that were passing close to 3 white dwarfs. For 17 years, they observed and analyzed transits. That's when the brightness of a white dwarf dips because of an object in a stable orbit passing in front of it. In the case of white dwarfs, we can predict such transits and use them to study the stars themselves and celestial objects passing by them. So, when something gets too close to a white dwarf star, the star's immense gravity rips it into smaller and smaller pieces of debris. The team has also found out that transits of such debris are chaotic. Plus, this debris is oddly shaped, which means that it is being devoured further. The first white dwarf used for studying the transit process, this guy, ZTF J0328-1211, seemed steady and well-behaved over the last few years. Well, until scientists found some evidence of a massive catastrophic event that occurred in 2010 or so. The next star, ZTF J0923-4236, dims irregularly every couple of months before brightening again. And the third white dwarf, WD 1145-5+1, used to behave close to theoretical predictions. It had transits that varied in numbers, shapes, and depths, but the latest study has shown that the transits are now completely gone. And this indicates the unpredicted nature of transits. One minute you see them, the next they're gone. The reason might be the chaotic environment they have to exist in. As for our own solar system, and our planet in particular, its fate looks pretty sad. Earth will be swallowed by the expanding sun even before our star turns into a white dwarf. As for the rest of the solar system, located further from the sun, some of the asteroids between Mars and Jupiter, as well as some of Jupiter's moons, will be destroyed later. They are likely to get dislodged and travel too close to the white dwarf. At the same time, astronomers aren't 100% sure that it's exactly what will happen with our solar system. Well, I guess we'll just have to wait and see. For like 6 billion years. Speaking of white dwarfs, scientists have recently found one that has a bizarre metallic scar on its surface. This blemish could have formed after the star ripped up and ate a tiny planet orbiting it. White dwarfs with traces of metal in their atmospheres aren't rare. These traces are left by planets falling into stars affected by their gravity. Experts have long thought that such metals should be distributed evenly across the surface of such polluted white dwarfs. But a new study has discovered a white dwarf with a weird concentrated patch of metal. This star, WED 8-310, was monitored over a period of 2 months with the help of the Very Large Telescope in Chile. The researchers found an opaque patch of metal. It was located over one of the star's magnetic poles and blocked some of the star's light as it rotated. Based on this position, astronomers concluded that the material could have been funneled into the star by its powerful magnetic field. This process is similar to the one causing auroras on Earth, where charged particles follow the magnetic field to the surface. The planet destroyed by the white dwarf was most likely very small, around the same size as asteroid Vesta in the solar system, which is a mere 525 kilometers across. Its debris is now prominently displayed on the host star's surface, It makes it easier for researchers to examine what the planet's geochemistry was before it was devoured. Such a study might even turn out to be one of the best ways to observe small worlds beyond the solar system, even if such a world has already met its demise. There might be many more scarred stars like this one. The one in question was the first, but probably not the last. Even better, astronomers have already discovered 2 white dwarfs that seem to have similar scars. Making repeat observations of such stars might help us unearth, pardon the pun, no, I meant to do that, unearth even more secrets and make more discoveries. Another bizarre white dwarf, discovered not so long ago, seems to have stopped cooling due to the formation of internal crystals. It challenges existing theories on star aging, and also questions the methods of stellar age estimation. But scientists might have understood why it may be happening. White dwarfs are believed to be dead stars. They keep cooling down over time, and normally, this process can't be reversed or paused. But in 2019, the European Space Agency's Gaia satellite discovered a number of white dwarf stars that had stopped cooling for more than 8 billion years. It might mean that some white dwarfs can generate a lot of extra energy, which is at odds with the classical dead star theory. At first, astronomers couldn't figure out how it might happen. In the end, more than 97% of stars in the Milky Way galaxy turn into white dwarfs. Astronomers have long thought that such stars are at the end of their lives. After depleting their nuclear energy source, they stop producing heat and cool down. Eventually, the dense plasma in their insides freezes into a solid state, and the star solidifies from inside out. The whole process can take billions of years. But the new research claims that in some white dwarfs, this dense plasma doesn't simply freeze. Instead, its solid crystals forming upon freezing become less dense than the liquid and start floating upward. They displace the heavier liquid downward. The movement of heavier material toward the center of a white dwarf releases gravitational energy, and this energy is enough to interrupt the star's cooling process and halt it for billions of years. This explanation actually matches all the properties of the unusual white dwarf population. But this is the first time such a transport mechanism has been seen in any type of star, and that's incredibly exciting. A totally new astrophysical phenomenon. But why does it happen in some stars but not in others? It most likely depends on the composition of the star. You see, some white dwarf stars are formed by the merger of 2 different stars. When they collide and form a white dwarf, it changes the composition of the star, which allows the formation of floating crystals. This discovery might mean that astronomers will have to review the ways they used to determine the age of stars. At the moment, white dwarfs are often used as age indicators. The cooler a white dwarf is, the older it's believed to be. But now, we already know about possible delays in the cooling process of some dwarfs. It makes the popular age determination method more unreliable. Some stars of a given temperature may be billions of years older than we previously thought. The recently uncovered transport mechanism within white dwarfs means that some of these stars can be shining as bright as normal for billions of years. This complicates age dating and the use of white dwarfs to reconstruct the formation of our galaxy. Hey, stay tuned! Are there real-life space monsters? Well, of course, there are no huge beasts made of stars that are flying through the universe. However, there are some things in space that truly remind us of things from our nightmares. The first one is the Eagle Nebula, also known as Messier 16 or Star Queen Nebula, a wonder located in the constellation Serpens. This dazzling nebula was discovered in the 17th century and earned its nickname from the visual impressions it creates. If you look at it, it resembles a giant eagle flying through the universe. It's a young star cluster, located super far away, about 5,700 light-years away from Earth. The Eagle Nebula spans a region of about 70 by 50 light-years in size. For comparison, our entire solar system is only 2 light-years long, with the distance between the Sun and Pluto being only around 5 light-hours. This enormous nebula is home to more than 8,000 stars. One of them is especially bright. It's a duo of massive stars, one about 80 times heavier than our Sun, and the nebula is actively creating new ones. Every day, the gas and dust in there are being compressed by the intense radiation and stellar winds from hot, massive stars within the cluster. This triggers the birth of new stars. And finally, in the heart of this nebula lie the iconic pillars of creation. These are vast columns of dust and gas, seen in blue, red, and green hues. They serve as active stellar nurseries. The dark clouds slowly draw together to birth the stars of the future, shaping the rich and complicated materials found in the universe. Pillars of creation stretch about 4 to 5 light years, so about twice as big as our entire solar system. The Eagle Nebula is remarkably interesting to astronomers. It's a wonderful place for us to study the star's birth and evolution. The grandeur of this place is amazing. However, it's more fascinating than frightening, unlike the following monsters. Quasars, captivating powerhouses, fueled by supermassive black holes at the hearts of galaxies. These black holes are millions to billions of times the Sun's mass. Matter spirals into them, forming a luminous accretion disk. Gravity within generates intense energy across the spectrum, making quasars shine brilliantly. Sometimes they can even outshine entire galaxies. These cosmic monsters have been intriguing astronomers for years. Quasars have the appearance of regular stars but have incomparable levels of energy. Their name comes from quasi-stellar radio sources. They're radiating across the spectrum: radio waves, visible light, ultraviolet light, X-rays, and gamma rays. We've been catching their signals for many years, but first glimpsed them only in the 1960s. Quasars are one of the most ancient objects in our universe. Their light, traveling billions of light years, helps us to learn more about the universe's early days, when these monsters were aplenty. They gradually dimmed over time, so we can only imagine how brightly they looked back then. One of the most iconic of them is Quasar Colossus. It's not one monster, it's a giant group of 73 quasars. Together, they're spanning 4 billion light years and outshine 100 Milky Ways. Something like that is impossible for us to even imagine. Our next monster is called a pulsar. When a big star goes out of its fuel, it goes boom. What's left behind after that is a neutron star, which has a mass several times that of our Sun, but crammed into a sphere as small as a city. They're super dense. Sometimes it teams up with some friend, like a companion star. If the companion shares its stuff with the neutron star, things can go wild. The extra material might make the neutron star collapse, becoming even denser. In that case, it would turn into a so-called quark star. But if it doesn't happen, the neutron star goes a different route. This immense density means that the protons and electrons in the star collapse into each other, forming a sea of neutrons, particles without an electric charge. This is when the so-called pulsars are born. Pulsars come with an incredible magnetic flare. These stars boast magnetic fields trillions of times more powerful than Earth's. The fun begins when this super-magnetized pulsar starts to spin. It's not a leisurely twirl. Pulsars can rotate hundreds of times per second. They're the fastest objects in the entire universe. As the pulsar whirls around, it shoots out beams of electromagnetic radiation. These beams act like lighthouses, sweeping across the universe with each rotation. If Earth happens to be in the path of one of these beams, astronomers detect pulses of radiation. That's where the name pulsar comes from. There's someone closely related to pulsars: the zombie stars. Sometimes, even after the star reaches the end of its life and goes supernova, it doesn't fade away entirely. Some matter might remain. In that case, it transforms into a celestial zombie. These zombie stars often appear in pairs, with one star giving in to its smaller companion. It acts like a vampire, feeding on other nearby stars, It drinks up hydrogen to come back to life. When it grows to the size of a planet, it bursts into a brilliant supernova again, destroying the star it fed on. Zombie stars aren't fussy eaters, they go beyond devouring stars. One of them is in the Virgo constellation, and it doesn't just munch on stars, it gobbles up the energy and stuff from its planets. And just like actual zombies are always on the go to find more food, these stars travel through galaxies. Recently, we found another one of them in a faraway galaxy. It's been traveling and evolving over the years, getting brighter, and this show started millions of years ago, back in the age of dinosaurs. Studying them can help us better understand how space objects work in wild conditions. It also helps us reveal secrets about fundamental particles and explore the physics of super-dense stellar leftovers. Now that we've met zombies, there are also cosmic vampires. Blue straggler stars defy aging by sucking life from their neighbors. They appear younger and bluer than their ancient companions because of that, confusing poor astronomers about their true age. Scientists studied 21 blue stragglers in a faraway 7 billion-year-old star cluster. That's when they made a breakthrough. They assumed that it was because of mergers or collisions. But then scientists revealed these sneaky stars as thieves feasting on nearby stars to stay forever young. While this discovery explains most blue stragglers, a few remain mysterious, which means that they probably have varied origins. Researchers plan to use the Hubble Space Telescope to detect their hidden companions and learn more about them in the future. Our final monster is an electric leviathan. In 2011, astronomers stumbled upon a colossal jet, spewing out of a galaxy with a funny name, 3C303. It's 2 billion light-years away. What made this discovery truly electrifying was the electric current it carried, an insane 1,018 amps. For comparison, a regular light bulb can barely reach 1 amp. This is equivalent to 1 trillion lightning bolts. This jet, powered by a supermassive black hole at the galaxy's core, extended over 150,000 light-years, surpassing the Milky Way's span. This faint galaxy, first observed in the 80s, was hidden from us for a long time. We only discovered it thanks to catching different wavelengths. Typically, jets emerge from galaxies with active supermassive black holes. Only around 10% exhibit visible matter-spewing jets. The secret to the record-breaking current of this little galaxy lies in the hyperactivity of its black hole. This black hole creates a super robust magnetic field, and this magnetic field creates this electricity leviathan. So, not only we find the universe's highest electric current, but it also marked a rare opportunity to study one of these large jets. Scientists keep making their equipment better to study it in more detail, so we can learn more about them in the future. Is there a giant megasun in the center of our Milky Way? Scientists actually thought so for a while because it's the brightest place in the galaxy. It has millions of stars packed into a small area. This area is called the galactic bulge. The galactic bulge has millions more stars per a light year than any other part of the galaxy. It can be 10 million times denser than our part of the neighborhood. In some cases, stars in this region are only 5 light days apart. That's like if there was another star in our solar system a bit farther away than Pluto on a space scale. But why is this place so dense? When galaxies form, a lot of gas and dust come together under the force of gravity. This material gathers up and eventually forms stars. Gravity and angular momentum balance out, and it starts looking like a flat disk with a pretty bright, bulging, dense core. The stars live their comfy lives, and once they get to the finishing line, they collapse under their own huge weight. Then, the black hole forms. Black holes love to eat everything around them, and the more they eat, the bigger they get. And what place is more perfect for fine dinner than the galaxy center, where all the space stuff is packed together? So it starts eating surrounding gas and dust, forming an accretion disk. As this material spirals into the black hole, it heats up and emits a lot of energy, which makes the center of the galaxy even brighter. That's why you can find both supermassive black holes and galactic bulges in the centers of all galaxies. The galactic bulge at the center of the Milky Way looks a bit like an ellipse. That's a classical bulge. Stars there aren't like our Sun. They move randomly in all possible directions and planes. Plus, they all move at different speeds. So gravity is going crazy there, and this makes the bulge look more like a sphere or an ellipse. Since they were the first ones to form, they have some of the most ancient stars in our galaxy. But there are also some places of star formations and lots of younger massive stars that are less than 100 million years old. As we move farther away from the center, things get a bit calmer. Stars start rotating uniformly and become stable. Right now, Earth is in one of the Milky Way's spiral arms called the Orion Arm, pretty far away from the galactic bulge. In our part of the neighborhood, stars are usually about 4 or 5 light years apart. This means that most of a galaxy is actually just black, empty space. Our black hole is called Sagittarius A star. It's a monster about 4 million times the mass of our Sun. It's also about 51 million kilometers in size, almost like the distance between Mercury and the Sun. But don't worry, it's not attracting the Milky Way inside it, and it's not going to eat us. These black holes are actually super small compared to the entire galaxy, so they can only eat whatever is around. Right now, many stars orbit Sagittarius A star, and even though it emits a huge amount of energy, we can't see its light from Earth without a lot of scientific effort. But why don't we see the center itself? The galactic bulge is so bright that even though it's 26,000 light years away, we should see it shining brightly in our sky. Yet we don't. Turns out it's all because of space dust. There is a lot of dust between us and the core, and it absorbs most of the visible light. We can only look at the galactic core using other types of light, like near-infrared, gamma ray, and so on. NASA has images of the core in different types of light, and it shows how scarily bright the center is without the dust blocking our view. But not all bright regions are blocked by gas and dust. For example, when we look at dense clusters like the Messier 13, the stars are so close together that they look just like a white spot. Most of our telescopes can't separate them from each other. The satellite galaxy M32, our neighbor near the Andromeda galaxy, has about 84 stars per light year. It's so dense that stars can't be resolved even by the Hubble Space Telescope. To get the idea, our solar system is 2 light years long. We'd see about 168 stars outside our window if we were there. Our closest star is Alpha Centauri. It's about 4 light years away from the Sun. If it was just a couple of light days away, it would shine much brighter than the full moon. So if we somehow managed to survive in crazily dense star regions, the sky would be white all day long. But it's unlikely that we'd make it. As we get closer to the center of the Milky Way, the chances of finding life get super slim. The gravity of stars is going wild with chaotic movements, so there are barely any planets around. On those miracle planets, the radiation from cosmic rays is skyrocketing. Supernova blasts and star collisions nearby become an everyday occasion, and all the gas around makes it basically impossible to breathe or even see properly. At the same time, as we move farther away, there are fewer stars around. Elements that are super useful for life, like carbon, oxygen, and iron, are produced by stars, so they also drop. Too much radiation is awful, but too low radiation means that there's not enough energy to support chemical reactions like photosynthesis, which is why, if there's extraterrestrial life, it would most likely be somewhere in the middle of different galaxies. But some galaxies get their brightness from a so-called active galactic nucleus. These are extremely energetic regions at the center of some galaxies. They shine much brighter than any stars imaginable, although it mostly shines only in certain parts of the electromagnetic spectrum. The brightness comes not from the stars, but from the accretion disk around their supermassive black holes. As the material slowly falls into a black hole, it gathers around it and creates this flat, spinning disk of gas, dust, and other stuff. Since the gravity and friction there are insane, this disk heats up and starts emitting enormous amounts of energy. Also, this disk spins incredibly fast, almost at the speed of light. Because of that, collisions there happen all the time, and they're unimaginably powerful. They release even bigger amounts of energy. Most galaxies don't have an AGN. Those that do, like the galaxy M87 in the Virgo constellation, are called active galaxies. There are also different types of AGNs, like Seyfert galaxies, radio galaxies, and finally, the winners of our space brightness competition, quasars. Imagine things so bright that they can outshine the entire galaxy they belong to. Quasars are a specific type of active galactic nucleus, the most extreme and luminous form. They belong to the supermassive black holes, the biggest ones in our universe. Quasars are like a combination of several things. First, they're the brightest accretion disks in our world, because of their behemoth black holes eating everything around. But they have some cool features. For example, they have powerful jets of particles that shoot out from the poles of the black hole at nearly the speed of light. These jets add up to the brightness of the quasar, although they can only be seen in radio wavelengths. The energy they emit is so intense that they can be seen billions of light years away. However, the nearest quasar to us is 600 million light years away, so we can't see them with backyard telescopes. So, when we look at a galaxy through a telescope, we usually see only the brighter core, not the outer parts. Unfortunately, our eyes just aren't made to see things like the active galactic nucleus, so these stars are the brightest things we can see. But what a beautiful sight it is. Recently, scientists have made an astounding discovery that can change the entire course of Mars exploration. Apparently, there are oceans of liquid water on the red planet, so the future looks bright. We could use this water to support future missions, and then even relocate to Mars, since we wouldn't need to worry about where to get this precious liquid, right? Well, there's one big problem. These oceans of liquid water are in Mars, so deep inside that we aren't likely to get there. At least, that's what a new analysis of seismic data collected by the Mars InSight lander claims. Huge reserves of liquid water seem to be the best explanation for some seismic quirks of the red planet. So all this precious water is out of our reach. But we need to find it to solve the puzzle of the aquatic history of our blushing, dusty neighbor. And the first thing we need to do is identify where the water is and how much of it the planet is hiding.
Navigation has confirmed that the parachute has deployed and we are seeing significant deceleration.
Now, our rovers are scurrying about on the surface of the red planet, gathering all the available data on the planet's surface geology. And it's getting increasingly obvious that Mars was once covered with water. Many factors, from Martian terrains to ancient dry lake beds and deltas, suggest that there was a time when the planet was quite soppy. These days, there's still some water on and right below the surface of Mars, but it's in the form of ice and nowhere near what Mars had in the ancient past. To understand how much of it could have been on the red planet billions of years ago, we must know where all this water went. There are two spots where the water could have gone: into space or toward the interior of Mars. Then, it could have been isolated as either liquid reservoirs or ice deposits. Currently, we don't have any way of measuring how much water once leaked away. But now we finally can find out more about the gooey center of the red planet. All thanks to the Mars InSight lander. It isn't operating anymore, but from November 2018 to December 2022, it was listening to the hums and rumbles and monitoring the activity below its feet. The thing is, acoustic waves, generated by seismic activity deep inside the planet, can change according to the composition and density of the material these waves are moving through. And scientists can get a lot of information analyzing the behavior of seismic waves. In this case, they used a model similar to those used to map underground oil fields and aquifers on our home planet. Then, with the help of this model, they analyzed the data gathered by InSight on Mars. They discovered that the best explanation could be that there was a layer of fractured rocks whose cracks were filled with water deep under the surface of the red planet. That layer could be at a depth of 11 to 19 kilometers. That's why it would be extremely tricky for future missions to get to it. And still, the new discovery could help us understand the Martian water cycle. Confirming the existence of a large reservoir of liquid water can help us sneak a peek at what the climate on Mars used to be, or what it could be like one day. And if once Mars had had a lot of water, it could have been habitable in the ancient past and might become habitable in the future. Water is crucial for life as we know it, so underground water reservoirs on the red planet could already be habitable. Maybe while we're talking, tiny microorganisms or even some tentacled creatures are living their lives in the comfort of their underground home. On Earth, super deep mines do host life, and the bottom of the ocean, with its immense, unbelievable pressures, isn't lifeless either. So far, we haven't found any evidence of life on Mars, but for now, it sounds like this place has the potential to sustain life. InSight data have shown that there isn't likely to be a lot of water ice in the upper crust of the planet, at least in the region around the lander. But if it turns out that there is a water-rich layer deeper below the surface and stretching around the entire globe of the planet, then there would be enough water to fill ancient ocean beds, and even more. Mars isn't the only place outside Earth where there is water, or where we might one day find water. Take the good old Moon, for example. On Earth's natural satellite, water can be found all over the surface, but it's not the water you might be imagining. On the Moon, water remains mostly as ice, and it's distributed unevenly. For example, the poles of the Moon are the regions that never receive sunlight. This is the reason they're extremely cold. So, it's no wonder there's a lot of ice there. The ice in these areas is also often mixed with the lunar soil and hiding deep below the surface. Then, there's Enceladus, the 6th largest moon of Saturn. In reality, it's not that large, just 505 kilometers across. In other words, this moon is small enough to fit inside Arizona. Ooh, we should try that. Interestingly, when the Cassini space probe first arrived at Saturn, researchers were expecting Enceladus to be a frozen ball of ice. But what they saw was plumes of icy particles and water vapor erupting from geysers on the moon's surface. It was clear that there was a massive ocean between the moon's rocky core and its icy shell. Then there's Jupiter's moon Europa. Scientists think that this world is one of the most promising places in the solar system when it comes to searching for new life forms. That's because Europa has a huge saltwater ocean as deep as 64 to 161 kilometers. And even though it's under a layer of ice that is likely to be from 16 to 32 kilometers thick, it's still potentially habitable. Astronomers believe that plumes of water might erupt from cracks in the ice shell and release the contents of the moon's ocean into space. The temperature, pressure, and chemistry are very different on Europa, and astronomers aren't sure yet how the ice behaves there. That's the main reason they haven't figured out yet how deep or large the water reservoirs on Europa are and how long they need to refreeze. But out of all the places where we could find water in the universe, the most bizarre is probably open space. In 2011, 2 teams of astronomers discovered a cloud of water floating freely among stars. It was the largest and farthest reservoir of water ever detected. So, this massive cloud of water vapor surrounds a black hole, but not just any black hole. This one's a quasar located 12 billion light-years away from Earth. The conditions around this quasar must be really special to create such an enormous amount of water. This cloud contains 140 trillion times the volume of all the water on Earth. That's enough to give every person on the planet a whole planet's worth of water 20,000 times over. Sounds wild, doesn't it? But there's something even cooler. Astronomers think this water cloud formed just 1.6 billion years after the universe itself began. This discovery is yet another sign that water has been around all over the universe, even in its early days. But here's the kicker: until they found this, scientists had never detected water vapor so far back in time. Sure, there's water in our Milky Way galaxy, but most of it's frozen solid in ice. This discovery really pushes the boundaries of what we know about water in the universe. Many sci-fi movies can make you believe that everything happening in space is accompanied by some kind of sound effect, which is a totally false misconception. In space, no one will hear you scream. There's no air in space. It's an almost perfect vacuum. And sound waves don't travel through a vacuum. They can't reach your eardrums and make them vibrate, sending signals to your brain. But it's a good thing, especially for astronauts on spacewalks. If not for the quietness of space, they would be constantly overwhelmed by the noise of solar storms. Huge space explosions sure look super impressive. Whether they're scientifically possible or not is another question. Blasts on our home planet look the way they do because of air and gravity. You see, the air functions as an oxidizer, and the outward pressure makes everything fly into the air and then collapse back to the ground. But this process is very different in space, and it looks even cooler. If a blast occurred in space, there would still be some fire despite the lack of air, because some kinds of fuels can act as oxidizers. But it wouldn't be the fire you're imagining now. This cosmic fire would look like an expanding ball of light. It would be a seemingly never-ending process due to microgravity and the lack of air resistance. Nearby spaceships would be in grave danger since the shrapnel would fly outward until something eventually stops it. All comets have beautiful long tails. It's nothing but a popular misconception. In reality, comets are very difficult space bodies to spot. They usually spend large amounts of time far away from stars. There, in the darkness of space, they remain rather inactive and completely frozen. Comets only get tails once they come close to a star. That's when they start warming up. This process makes them form some kind of a cloudy atmosphere, which is called a coma, and a distinctive tail. The tail always points away from the star that influences the comet. It happens because the tail gets blown in the opposite direction by solar radiation and solar winds. That's why the tail can often be in front of the comet, not trailing after it. The inner and outer planets of the solar system are separated by the asteroid belt, a ring of asteroids and other debris and space objects orbiting around the sun. While creating movies about space, filmmakers make sure to somehow use this region. Usually they show the asteroid belt as an extremely crowded place, with dense clouds of huge rocks you have to skillfully maneuver through to get to the other side. In reality, if you looked outside your spaceship while flying through this region of space, it would feel as if you were looking at the sky from Earth, all because of the ginormous distances in space. If you decided to cross the asteroid belt, there would be very little chance of a collision with a space object. Asteroids there are really spaced out and very far from one another. Black holes are giant, scary cosmic vacuum cleaners, they say. But in reality, black holes are more like fly traps. They don't look for things to munch on. Instead, they sit out there quite passively. Only when a star, or any other object, comes too close does a black hole spring into action. Even so, only those space bodies that cross a certain border get ripped apart. In fact, black holes aren't any different from any other celestial body, since their pull is directly proportional to their mass. They can't swallow anything bigger than what their size allows. Even if our sun was somehow replaced with a black hole as massive as itself, nothing would change for Earth or any other planet in the solar system. Gravitationally speaking, of course. Space battles in movies often involve using lasers. But if you were to see such a fight from up close, you would probably be disappointed. The thing is, it would be like nothing in movies. A laser beam is a concentrated burst of energy, and it could indeed be used for many purposes during a fight. But a real-life laser beam would be totally invisible in space, since there wouldn't be any particles around to scatter the light and make the beam bright red or green or any other color. A human would be torn into pieces if they got into open space without a spacesuit. Well, contrary to popular belief, taking off a spacesuit during a spacewalk wouldn't be as dramatic as it is often pictured in movies. A person would just lose consciousness due to a lack of oxygen after 15 seconds of being in outer space without protection, but that's if this person breathed out as much air as possible. Otherwise, this oxygen would damage their lungs from the inside, making them rapture. After that, without the protection of the spacesuit, the pressure inside their body would drop. This would cause even more serious trouble, and even though this person definitely wouldn't burst, they wouldn't want to stay outside for too long. People often believe that in space, you experience zero gravity, hence the weightlessness astronauts feel on the International Space Station. But that's not exactly true. Gravity is one of the most important forces that exist in the universe. Thanks to it, the moon orbits Earth, and the sun doesn't float away out of our home Milky Way galaxy. Astronauts on the ISS do experience the effects of gravity, but that's not full-fledged. It's microgravity. The gravity on the space station is only 10% weaker than the gravity on Earth's surface, but astronauts are constantly in free fall. The spacecraft, people inside, and all the objects aboard keep falling forward, not down, but around our planet, following a specific orbit. And since they're all falling together, the crew and the stuff inside seem to be floating. That's why astronauts can move things as heavy as hundreds of pounds with their fingertips. And even though microgravity is often called zero gravity, they're very different things. A light year must mean time, right? Not really. Light years actually measure distance. NASA's definition of a light year goes like this: the total distance that a beam of light moving in a straight line travels in a year. And since light moves at a speed of 300,000 kilometers per second, a light year equals 9.6 trillion kilometers. It may seem as if the sun is always on fire. At least that's what it looks like in pictures and in movies. But in reality, our star is a giant ball of gas. Nuclear reactions happening in its core at all times make the sun burn. Every second, hundreds of millions of tons of hydrogen are converted into almost as much helium. During this process, huge amounts of energy are released as gamma rays. Then these rays turn into light. In other words, the sun does emit blinding light and incredible heat, but it's not actually on fire because no oxygen is involved in the process. The speed of light is believed to be the ultimate barrier for people when it comes to space travel, and it's often thought to be impassable. There are many theories about what it might be like to reach that speed, but none of the equations account for going above it. And still, we know that at least one thing in the universe is faster than the speed of light: the rate of its expansion. Yep, the universe is expanding faster than the speed of light, baffling astronomers and casual skywatchers alike. Or at least we can say so in terms of the speed of different objects, like faraway galaxies relative to each other. At the moment, it's not something scientists understand well. The rate of the expansion of the universe is proportional to how far something is too. The farther it is from us, the faster it's moving away. But even though we don't get the mechanics of it yet, we've got our proof, even though it's theoretical so far, that some particles might be able to travel faster than the speed of light. Some scientists think there could be more things out there in space that could challenge this speed barrier. All we need to do is find them.